Okay, in this lesson, we're going to be talking about linear inequalities. And a linear inequality is simply an inequality. Remember the greater than or less than. An inequality with two variables, x and y, that can be graphed. Okay. A solution to a linear inequality is any ordered pair. I'm running out of ink. That makes the inequality true. For example, determine which of these ordered pairs are solution to this linear inequality, 2x minus 3y is less than 15. If you'll notice, there's x's and y's in here, which is what an ordered pair consists of, an x number and a y number. So solutions to this would be any ordered pair that when I plug this x number in for x and the y number in for y and simplify, if it's a true statement, then it would be a solution. And if it's not a true statement, then it would not be a solution. So let's try this x number of 2 and y number of 5, plugging them in. So that inequality becomes 2 times x, but I'm substituting in this 2 for x. So 2 times 2 minus 3 times y, which is my 5, is less than 15. And I'm not saying it's less than 15. I'm asking, is it less than 15? So let's see. Well, 2 times 2 is 4. Negative 3 times 5 is negative 15. 4 minus 15 is negative 11. And negative 11 is in fact less than 15, so that would be a solution. So I would go through these and check each one. So negative 1, negative 7. I'm going to plug in a negative 1 for the x and a negative 7 for the y. And I'm going to see if this is a true statement. 2 times negative 1 is negative 2. Negative 3 times negative 7 is positive 21. Negative 2 plus 21 is 19, and 19 is not less than 15, so this would not be a solution. So that's how you check them. Zeros are always the easiest. I'm going to skip this one and go to this one. I'm going to plug in a 0 for x and a 0 for y, because zeros are easy, because when you plug zeros in, these just become 0. 0 minus 0 is 0, and 0 is less than 15, so in this case that works. Okay. So if we're asked to graph a linear inequality, okay, first thing you want to do is put the inequality in slope-intercept form. Okay, remember, y equals mx plus b. We always begin with our b number and use our slope to find our next point. Here's this special rule we talked about. Be sure to flip the inequality symbol if you multiply or divide by a negative number. Okay. With the line, once you get the points to graph, and I'll show you how to do this, you're going to draw your line, but your line is going to be either solid or it's going to be a dotted or a dashed line. It's a solid line. We're going to use a solid line if you have the equal bar. It's kind of like the same thing as a closed circle. So if you see a closed circle, or if you see the equal bar, you'd use a closed circle on the number line. When we're doing the graph, if you see the equal bar, then we would use a solid line. And if you don't see the equal bar, kind of like an open circle, it would be a dotted line, or kind of like an open line. Okay. And I'm going to show you how to do all these. They'll come together. Okay, we're going to shade below the line. Remember when you draw our arrow to the left or to the right, usually on the number line? Well, now we're going to have a whole graph, and I'm going to show you what it means to shade. But for right now, the rule is shade below the line if the symbol is less than or equal to. Shade above the line if it's greater than or equal to. Kind of think like this. Less than means smaller or below. Greater than means bigger. Bigger is above. Okay? So if I wanted to graph this linear inequality in two variables, the first thing I need to do is put it in slope-intercept form. I need to get y by itself. So if I want to get y by itself, I need to move everything over to the other side of the equal sign, the inequality sign, except for y. So I would start by taking away 2x here, which means I need to take away 2x here. And that leaves me with negative 3y is less than 15 minus 2x or minus 2x plus 15. I'm just putting that in the front, negative 2x, and putting the 15 in the back. Now to get y by itself, I need to do one more thing, which would be divide by negative 3. And now this becomes just y. I divided both sides by a negative, so I need to change my sign. This will not divide evenly, so I'm going to leave it as a fraction, but I've got some cleanup to do. A negative divided by a negative is a positive, so these negatives, they cancel each other out and leave me with 2/3 x. And 15 divided by negative 3 is negative 5. And now it's in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. When I go to graph, I always begin with my b number, which in this case is negative 5. So remember, it's the y-intercept. The b number stands for the y-intercept, where it touches the y-axis at, which in this case will be negative 5. 2, 3, 4, negative 5. Now from there, I'm going to use my slope, rise over run, to find the next point. Rise 2 and run 3. And then this will be where my boundary line is going to be. Okay, I'm just going to connect these dots. However, when we go to graph the line, we now have to consider, is this a solid or a dotted line? Anytime there are inequality signs, you have to take this into account. If there's an equal bar, it's a solid line. If there's not an equal bar, it's a dotted line. Well, there is not an equal bar here, so it's going to be a dotted line. So my boundary line, rather than just drawing a solid line like I normally do, I'm going to draw a dotted line or a dashed line. And now this shading, let me show you how this works. What we're looking for are the ordered pairs that are solutions to this. Well, the ordered pairs that are solutions to this either fall above this line or fall below the line, one or the other, but not both. Well, since my symbol is greater than means bigger, which means I'm going to shade above the line. So above this line would be up above it. So my shade, I'm going to throw some shade just like that right there, would be all that area above the line, not below it, which represents any ordered pair in this shaded area represents a solution to this inequality. Any ordered pair over here in this area that's not shaded would not be a solution. Any point on the line, in this case, because it's a dotted line, would not be a solution. If it was an equal bar, we would have a solid line. Those points on a solid line would be a solution. Let's look at a couple more examples. We'll be all done. This one is already in slope-intercept form. So this is my slope, and this is my b number, so I'm going to begin. I know it's in slope-intercept form because y is by itself. So I'm going to begin at negative 5. 1, 2, 3, 4, 5. And I'm going to put a point. My slope is 1/3. Up 1 over 3. Up 1 over 3. I could also go down 1 and back 3. I'm going to do that until I fill up my graph. You'll see why. Okay. Now I need to connect my line. And I have to consider whether it's going to be a solid or a dotted line. And because this does not have an equal bar, it's going to be a dotted line. Therefore, my line would look like that. And now I have to consider the shading. And this is greater than. Greater than means above. So I would shade everything above that boundary line. That's how we graph them. Let's look at a couple more. This one's y is by itself, so I know that's my slope and that's my b number. I'm going to begin at negative 1. This one's going to be different than the last one. And then I'm going to, remember my slope has to be a fraction, so I'm going to make the negative 2 and I'm going to put that over positive 1. So from here I'm going to rise negative 2 and run positive 1. Down 2 and over 1. I can keep doing that until I get to the end of my graph. And now I'm going to connect these with the boundary line. And because my symbol has an equal bar, it's not going to be a dotted line. It's going to be a solid line this time. So I'm going to connect these dots with a solid line. And now I need to consider my shading. This symbol is less than or equal to. Less than means I shade below the line. So below the line would be this area down here. If you're confused on whether you're above or below or how to find above or below, put your pencil on the line, and if I want to go below, I'm going to go 1 unit down, and now I'm below the line. So you know that it's going to be this area here. Everything below that line. And again, the shaded area represents solutions to this. And in this case, because it's a solid line, the points on that line would also be solutions to this. All right. Let's see. Let's look at number 6, last one. I'm going to get y by itself because it's not by itself, so I'm going to take away 3x, and I'm going to take away 3x. So I'm left with 2y is less than 0, take away 3x. Well, that 0 just goes away. Leaves me with 3x. Divide here by 2 and divide here by 2. And I'm left with y is equal to negative 3 over 2x. So you see what's missing now that I have y by itself. What is missing is a b number, which means that your b number in this case is going to be 0, which means it's going to cross right there at the origin. And this would be my slope because it's the number in front of x. So I'm going to rise negative 3 and run positive 2. And I can go up 3 and back 2. And it's still going to give me points in the line. Because there's no equal bar, I'm going to draw a dotted line. Get off a little bit. You see my point? The symbol is less than, so I'm shading below that line. You must take into consideration a solid or a dotted line and where the shading is every time it's an inequality sign. So I get students that ask, do I need to shade? And if it's an inequality sign, the answer is yes. Here's one. X is greater than 7. Crosses the x-axis at 7. This one is a vertical line. Greater than 7 is over here on this side. So if you remember how to do those, remember if there was only one variable like 7 and 8, it's either going to be a vertical or horizontal. Okay, that is it.